Friday afternoon. I know some of you aren't often in school at this time. I'd like to introduce Tron, Jeremy and Jesse, all from Medici Ventures. They're working quite heavily on the Ravencoin project. Medici Ventures is run in Salt Lake City by out of Overstock. So Overstock, a lot of you guys might have heard of them, big e-commerce business, and they've started Medici Ventures as a way to kind of test the water with blockchain and also help internally develop some of these projects. Ravencoin is one of them. I'll let Tron tell you a lot more about the project and what they're doing, and about how Ravencoin are trying to help digitize assets and make it a lot more fluid environment for investors in the future.
Thank you. So my understanding is that some of you are from a blockchain meetup type thing or school group, and some are from the wider business school. How many are familiar with Bitcoin? Okay, how many are familiar with how it works? Okay, how many have heard kind of the term blockchain thrown around, that type of thing? Okay, how many are familiar with the layer 2 assets? So this would be something like a counterparty or a master coin or an omni, something like that. Okay, not as many, maybe a third. Okay, so I'm going to start. So I'm the lead developer on Ravencoin. These are some of my colleagues. Jeremy does a lot of the work on the new stuff that's added, and Jesse helps manage the project. And we have some other developers that in Overstock. So Overstock is a wholly owned Medici Ventures. Medici Ventures is a venture capital firm that invests in blockchain companies that work on several pillars. So capital markets, real estate or land titling rather, and some other kind of areas that they focus on in investing. So this talk is mostly about Ravencoin. I gave this talk yesterday at the Free State, New Hampshire Blockchain Conference. That was that yesterday? Mm-hmm. Yesterday, yep. So some great things happened yesterday. We actually got added to Binance. How many of you are familiar with Binance or, okay, like it's Bittrex, Coinbase, that kind of thing? Okay, so Binance is one of the bigger ones. We were added to that yesterday, which is kind of a big deal for us. Just lost the screen. There we go. Okay. Play this. This is actually done. The audio may not work. If the audio doesn't work, I may skip this one. So this is done by a community member. This is an open source project. So we have a lot of people working on the explorers and different things to kind of work with Bitcoin. And we work on the kind of the core protocol, like the Bitcoin core stuff. So what is Ravencoin? So Ravencoin is a cryptocurrency based on a fork of Bitcoin. So this is a code fork, not a chain fork. So the people who had Bitcoin didn't get Ravencoin automatically, which kind of happened with some of the other coins, Bitcoin Cash, etc. But it's a platform for anyone to be able to create their own asset. So because just a few of you were familiar with how counterparty works and things like that. So somebody came up with this idea, with Bitcoin being a very secure ledger. Somebody came up with this idea that they could take and issue tokens on top of the Bitcoin platform. And they do that by basically using what is effectively like the comments field or whatever in Bitcoin. So since Bitcoin, you know, these transactions are immutable and you can't change them, they could stick something in the comments field that says, hey, we're going to issue a token, and you can just kind of a name of a token and a quantity, and stick it in the comments field of a regular Bitcoin transaction. You have to send some Bitcoin to keep, so the transaction goes through the Bitcoin network. But this comment field said, all right, on this block, this transaction, this asset is issued. And by asset, I just mean a name and a quantity. And then from there, you basically, they would point to, there would be another protocol, and by that I mean another piece of software that would scan through the Bitcoin blockchain and look for these issuances and look for any transfers. And transfer had a specific format, and they would say, hey, it's going to reference a transaction that's up above and show transfers and movements, similar to the way Bitcoin works, but with Bitcoin almost not being aware of it. Right? It's just this permanent ledger, and Bitcoin's kind of oblivious to it. There's just these comment fields that just kind of ignores that data, and there's this other software kind of scanning through and saying, oh, there's an issuance, there's a transfer to and from addresses. So this exists. There's several protocols like this: Open Assets, Colored Coins, Mastercoin, which is now called Omni. If you're familiar with Tether, Tether runs on top of the Omni protocol, and Counterparty. These are the biggies. And they're very, very secure, but they're a little bit clunky because you have to have some Bitcoin to use them. You have to send some amount of Bitcoin with every transaction. Otherwise, the Bitcoin network goes, hey, you can't use this transaction. It doesn't have any Bitcoin in it, and it just confuses it, so it just throws it out. So you have to send some Bitcoin with every transaction. So the goal of Ravencoin was to fix some of those clunky aspects and to make it so that when you transfer these transactions, it doesn't require any Ravencoin to move with it. It may require some Ravencoin as a fee to use the network, to use the Ravencoin network, but it doesn't require that you move some Ravencoin with every asset transfer. So this is the ability to create your own token. So what is a token when you create it? How much is it worth? 0, right? You can create these with almost no amount of work at all, a little bit of cost of Raven, at least on the Ravencoin network. You have to burn some Raven, which costs you maybe, right now, costs you maybe $8, $10. Create an asset, and you can create them for yourself, and you can say, I now have 21 billion, and you get to pick a name, whatever, Bob Coin, and then you own them. But it's really up to you to make them worth something. And that's where that's kind of the rest of the talk, really. That's how that works. So how many familiar with ERC20? Okay, half. ERC20 runs on Ethereum. It does this same type of thing, lets you create a token. It's also clunky. You have to have a contract. For those of you who are familiar with Ethereum, they have smart contracts, which is code that runs on every node. And somebody built a template contract that says, hey, we'll just make a template contract, which is just a small program that runs on every node identically. And the contract will have these few functions: issue and transfer. And so you can create your own asset using ERC20 contract template and create your own assets. And so the problem is it's a little bit clunky. You can pick a name and you can have it named, but you really have to have that contract ID. And if somebody picks the same name, they just have a different contract ID. They're unique because they're a hash. So what we've done is removed a little bit of the clunkiness when we built this kind of right into the protocol. And since we're not trying to be a generic smart contract, we can do a lot of things that make it easier to use. So even your grandma can create an asset on their phone. This is the current Ravencoin dev team. Myself, Jesse, Corbin, Mark, Jeremy, right here. Cade does a lot of DevOps. Daben, if you're ever on our chat channels, so we have Discord, Telegram, etc. He's known as Chaturga, that's his code name. And Roshi, who actually visited us from Morocco. I forgot that yesterday. He's not happy that I did that on video. So he came from Morocco, came to visit Salt Lake, flew on his vacation, spent his own money, came, worked with us, worked for about a month. Did such a great job, we hired him as a contractor. So now he kind of bounces back and forth between our office and Morocco. But there's lots more people involved. So this is a bigger project than just Medici, than just Overstock. There's a lot of people contributing to it to build kind of the ecosystem in the same way that Blockstream is kind of paying some developers right now to work on Bitcoin. Overstock, Medici are paying us to kind of help with the core protocol, with other developers working on kind of the wider ecosystem. So this is how it started. Bruce, who's not here, but he ran the conference, the Free State Conference yesterday. It was his brainchild, it was his idea. He talked to Patrick Byrne, he's the CEO of Overstock, and they said, hey, yeah, let's make this happen. So he mentioned it to me. I thought, that's a great idea. I want to be involved with this. And so we started building it. He announced it before this and was going to have some developers out of another country work on it. He tried that. That didn't work out. So we kind of took over the project. We launched on January 3rd, 2018. We did this on purpose. This is actually the 9th birthday of Bitcoin. Bitcoin was launched on January 3rd of 2009. It launched with a Genesis block text. It was just some text that was embedded in the Genesis block that said the Chancellor bails on the brink of second bailout of banks. That was from the London Times. We also picked a London Times article that mentioned Bitcoin, said companies are using Bitcoin for something. It's in our Genesis block from the same publication from the same date 9 years later. And so we released the code, we started it up, people started mining it. Unlike, how many are familiar with the term ICO? A lot, okay, that's interesting. More than even Ethereum. Most of the ICOs run on top of this ERC20 contract that I was talking about. ICOs got a lot of press last year. People were just raising money like crazy. Back in 2013, kind of when I started, the idea of someone creating a coin and then pre-mining or having tokens that didn't have a value, that weren't mined into existence, but were just poof, created into existence, was horrible. That was horrifying for people. People were like, this is a scam, you can't do that, it's a pump and dump, it's a, there's just all kind of negative terms for it. And then in 2017, it was like all the rage. I've created this token, please give me some Ethereum or Bitcoin or whatever, I'm gonna raise it. Here's my white paper, this is what I'm gonna do. Give me some money and I'll build this project. That was huge in 2017. It has some legal ramifications. For those in the business school, you probably end up hearing about this, but the SEC doesn't really care for this. And I'll talk about that in a little bit. So this is Bitcoin. So for those of you who aren't familiar with Bitcoin, it has 21 million coins ever. About a little over, not quite 7/8 of them have been issued so far. So the rest of them will be issued over the next 100 years or so. 10-minute blocks. This just means that transactions are gathered up kind of on a 10-minute thing, put into a block, and then the miners work on the block header and solve it. And then whoever solves that block, and I'll kind of explain what that means because we changed it a little bit for Ravencoin. Whoever solves that block gets 50 Bitcoin initially. After 4 years, then it got 25 Bitcoin, and right now we're 12.5 Bitcoin. Now let's just keep cutting in half. And for those of you familiar with kind of geometric thing, it basically trails off until there's no more being issued. It uses SHA-256 mining. I'll talk about mining in just a little bit. And then initially 50 BTC reward, which is how much you got for solving the block. So Ravencoin, 21 billion coins with a B instead of an M, so 1,000 times the issuance schedule. Runs a little bit faster, so we collect transactions on a 1-minute schedule instead of a 10-minute schedule. We also changed the mining algorithm, so we came up with our own called X16R. There's a reason for that. I'll explain that in a bit. So 5,000 Raven reward. So instead of getting 50 Bitcoin initially for every block solved, you get 5,000 Raven. So that you have a mining rig, or even a mining computer. It's just really a gaming computer as long as you have a decent video card by NVIDIA or AMD, which is most. Most of the decent video cards are by those two companies. Then you can run some software and get Raven just by plugging in your computer, running some software that's freely available, and you can just mine blocks. And you can work with others in a mining pool, so even if you're not solving a whole block and getting 5,000, you can basically send your hash power or work on it in collection with everybody else. When the pool solves a block, it pro rata sends you out some Raven. So this exists on lots of different coins. This isn't magic or unique to us. So after launch, so a lot of this we wanted it to be community run, so the community runs the Telegram, the community runs the announcement on Bitcoin Talk. We had the first Raven mining pool. We finally wrote the white paper, so we integrated into the software before we wrote how X16 works. Somebody wrote a song, first Ravencoin song, actually quite literally wrote a song, sent it to us. That was the first Raven song. I met the husband of Ravencoin girl, was the person that wrote these songs, and it's been awesome. She's written 4 songs. We had the first Ravencoin meetup in New Hampshire. If you're interested, Jesse and I are in that. We're just sitting there in kind of a couch and kind of like fireside chat. It's on YouTube. You can look that up. Ravencoin was added to exchanges, so this is the ability for people to get it that weren't able to mine it and want to just buy it. They just want to buy some Bitcoin and then turn that into Raven. It was added to exchanges. We had our second Ravencoin song, Fly Like a Raven. Our roadmap was released. People were kind of saying, all right, so you've done this, you basically copied Bitcoin, who cares, right? You've made some changes, who cares? What are you going to do? What is this going to be? Why would I buy some? Why should I invest in it, et cetera? They wanted a roadmap. Where are you going? So we finally released that. We had the plan from the beginning, but it wasn't well written up, I guess. Then we got the third song on April 8th. It was added to Bittrex on August 13th. We had a problem where there was some fluctuation in the mining, so we fixed this. Is kind of a big deal for us, fixing the algorithm so it slowly adjusts the mining. So that was on August 29th. These other ones are fairly recent. So on October 8th, we released the iOS Ravencoin wallet. So if you have an iPhone, you can go to the Apple Store, download the Ravencoin wallet. If you have an Android, you can go download the Ravencoin wallet from Google's Play Store. We also released this was Monday, right before we left for this trip. We released Candidate 0 for asset support. And asset support is this new ability to create your own asset, right? Just to be able to create it. Doesn't exist yet. It will be activated sometime the first week of November. So at that point, we expect people to create assets. There'll be some, we expect some name squatting, like if you tried to get, you know, like Google.com or NFL.com, some people will try to get these names because unlike ERC20, the names are unique. So first person to get it kind of reserves that name. Second Ravencoin meetup in New Hampshire. This was written yesterday, so yesterday. And then the asset feature voting, so the activation of assets, which has been almost a year in working on it and testing it and building it, will be activating in less than a month. So I won't dwell too much on this. We changed the mining algorithm for mining geeks. This is interesting. For everybody else, not as much. This picture's here because we came up with it while we were sitting there eating wings at a company, at a restaurant near our office. So what is mining? I'm going to talk about this real quick because I think it's helpful for people to understand what mining is. It's kind of a mystery. It feels like you're digging for gold or something. It's not quite that. So mining, how many are familiar with what mining is? Like Bitcoin mining. Okay. All right. For the other half of you, I will go through this fairly quickly. So how many of you know what a hash algorithm is? About the same people that know what mining is. Okay, so a hash algorithm is just code. It's just a program where you take any chunk of data. It could be a movie, it could be a PDF, could be a Word document, doesn't matter. You throw it through this algorithm and you get a number between 0 and 2 raised to the 256. Right? So very, very, very large number. Just to give you an idea, that's 10 to the 77th or a little bit larger than that. Which is roughly the number of atoms in the known universe, right? Which is 10 to the 78, 10 to the 79th. I mean, it's kind of an estimate because the universe is pretty big. But it's in that ballpark, in that range. This is a huge number. I mean, number of atoms in the universe. So that's a big number. You throw a different file through, you get a different number on this number line. So imagine this is the number line, grade school number line, 0 to the 256 over here. Different number, and it's very random, except that if you throw the same file through the same algorithm, you're getting exactly the same number. So that's what a hash algorithm is. There's lots of different ones. The one that Bitcoin uses is SHA-256. It's a known algorithm. So it's used for lots of things in Bitcoin, but that's what a hash algorithm is important for the story of mining. So the way mining works is you take a block. A block is just all the transaction data for transaction, meaning I want to transfer my Bitcoin from this address to this address, right? It's just, some bytes that say that. And so that's a transaction. You take all the transaction, you put them all together, enough that'll fit in a block, and the block header, which is just 80 bytes, has a version, right? Just the version of the, like where we are, and just, changes kind of every once in a while when you change the code. The previous block hash. So this is a hash. So this is one of these numbers on this number line, but it's the hash of the one from the previous block. This is the only thing that chains blocks together, right? So you have a block, and you put the block hash of the previous block in this block, and that's the only thing that chains together. That's the only thing that makes a block chain, is the fact that this hash came from the previous block, and you couldn't have known it until that other block was solved. You couldn't have known this number, and so you can't build on the block until you know the previous block's hash, and then you can shove it in here, and then you can start working on the next block. So nobody can kind of work on previous blocks or other blocks until they get the solution to the previous block. But that's also what makes the blockchain. The Merkle root that's kind of a mathematical thing where you take all the transactions, you do a hash of all of them, and you kind of put them all the hashes, like in a line, you pair them up, and then you pair them up and you take a hash of that, you pair these two up, make a hash of that, pair them up, hash of that, and then you have a bunch like here, like bowling pins, right? There's the back row and then the next row, and you kind of hash them until you get one number right at the top. That's the Merkle root, it's the hash of that, and you stick that in there. It's another one of these huge numbers. You stick that in there. The nice part about that number is if any of the transactions in that block change at all, then the hash, one of the hashes would have changed, which means the hash of this would have changed, the hash of this would have changed, and the Merkle root would change, right? So this one number, right, that you can stick in there proves that none of the other transaction data has changed. If it changes at all, one byte, one anything, one bit, that Merkle root will change. We have a timestamp, we have a difficulty, we'll talk about that. It's actually represented here by this green rectangle. It's kind of the width of on this number line. It's like a small number that kind of says, all right, we need to be in this area. And I'll show you why that's important in a minute. And then you have a nonce. So a nonce stands for number used once, and I'll explain how that works. So you have a nonce. What you're going to do is take this nonce and set it to a number. Doesn't really matter what number. You're going to run a hash, and you're going to get a number on this number line. So that's what mining is. Okay, that's all you're doing is setting that nonce, doing a hash, and getting a number on this number line. But you're trying to get that red dot into this green rectangle. You're trying to find a low number. That's the goal. So it didn't happen this time, so we'll change it again. We'll increment this nonce, and we'll get another dot, and it missed the green rectangle. So we'll do it again. Right? So we do this again, we get another number, not the green rectangle. We just keep doing this. Do it again, 3, get another. So I have a machine at home. It does this 3 trillion times per second. It takes a lot of power. I have to plug it into 2 circuits, right? It takes enough power that it would blow any one circuit in my house if I plugged it both into the same circuit. It is obsolete. It does not run fast enough or not efficient enough. The machines today are 14 trillion attempts per second, and you can plug it into 1 circuit. So I don't run my machine because I'd be losing money if I was trying to mine Bitcoin. So it's basically a big paperweight. Don't worry, I made enough money back when it was when it worked. So let's say we keep doing this, and we're running through these nonces, and eventually we find a winner, right? We found something that's in this low number, within this difficulty range. It kind of tells you how wide this is. So we found a winner. Since we got to construct the block, and in the block we got to put what's called a Coinbase. For those of you familiar with the company Coinbase, totally different thing. It was named after this. The Coinbase is, I just get to put a record in there that says I get 12.5 Bitcoin and send it to my address. Or if you're mining with a pool says we collectively get 12.5 Bitcoin and it comes to our address that we're going to distribute from. So that's what mining is, right? You've solved this block, you found something in the difficulty. So why the difficulty? Well, the difficulty adjusts automatically by the software. The width of that green rectangle adjusts so that there's a block found approximately every 10 minutes. If it's happening faster than 10 minutes, that green rectangle will get narrower, so fewer of these will hit in this area. And if it's happening slower, then it will widen the rectangle so that we're back on the 10-minute track. Same thing happens in Ravencoin, only we adjust it so that it's 1 minute. So we look back at the blocks and say, how fast is it happening? So that's mining. So now you know, kind of take the mystery out of mining. So one thing we did change. So Bitcoin uses SHA-256. Anybody have a question? Oh. Yes. Yeah.
Is throwing darts?
Yes.
Yeah.
Yes. It's a very random process where eventually somewhere, with all the people doing all the work that they're doing in mining, somebody will find something. It's very, very random, intentionally random. I mean, there's no way to predict what that nonce is. There's no way to back solve it. But once you solve that block and throw it out there and say, hey, I solved it, it's a fraction of a second, trillionth of a second for each node to say, yep, hey, this is a solution, we'll take it. Yeah.
Many miners are working on the same block?
Yes. So when I say trillions per second, that's like one machine. There's farms in China where there's like rows of warehouses. They're using power from the Three Gorges Dam. They're using tons of power. Stuff in Iceland, Washington State, because it's cheap power, hydro. Yeah, it's just the collective, everybody who's working on it. That green rectangle will get smaller and smaller, so that still with everybody working on it and everybody getting equivalent of like what is $60,000, $80,000 when they solve a block, that basically they're going to find one every 10 minutes. That's the goal of the software, is to make it 10 minutes, no matter how many people work on it. Whether it's originally a couple of guys with the laptops, 10 minutes. Now, thousands of mining farms, that's their whole business, 10 minutes. And it just adjusts that width of that rectangle. Yeah?
Can you partially solve for it? Like, if I have a laptop open and
Nope.
I have 10, 15 minutes to do it?
Nope.
Like, how are you competing against those people in China? Are you working with them? Or just
So it is quite literally a, think of it, each hash as being a lottery ticket. You're kind of randomly changing that nonce and getting kind of a number on this number line that's, you know, and you hope it's in that range, and if it's not, you try again. So when you do share work with others, the pools, what they do is they send that block template, and they say, hey, you work on these nonces, I'll work on these nonces. If we ever solve one, and that may or may not happen before the 10 minutes, and as soon as somebody finds a block, you have to start over. You have to build a new block template and start over, right? So everybody's working on it, and then they go, oh, somebody found a block. Well, all right, start over. But it's quite literally like a lottery ticket, one in, like each hash is, I mean, it's now exahashes. I mean, it's trillions of trillions, chance each hash, and you hope that you have a machine that, but even a laptop could be plugging along, and they have a one in multi-exahash per try, and it can do a few thousand tries, where the other guys are doing multiple trillion tries, but you still have an equal chance per hash. It's just that you're not hashing as efficiently as everybody else. Yeah, and the pools are just basically, once they solve it, because you're working in conjunction with the people in your pool, once it solves it, oh, there is a partial solution, I apologize. There is a partial solution, and the pools use that. They make the rectangle wider, and they give you credit, partial credit, in a database for finding one that was close. And all that does is say, hey, I was trying, and I was working on this block, and I was working on it, and they'll just basically kind of give you a credit, check mark credit, and that's how the pools pay out when there's a solution. The partial credit's worth absolutely nothing, but it's enough to say, hey, you were trying and had to do a whole bunch of hashes to find one that was a little bit outside the rectangle. So there's kind of a partial solution. It's just not worth anything on the network. So we modified the hashing algorithm a little bit. Bitcoin uses one hashing algorithm called SHA-256. We basically combined 16 different hashing algorithms. So they have that same property of take data, come out with something on the number line. All 16 of these have that property. And so what we do is we chain them together. And so what happens is we look at the previous block hash, right? Which means that no one has that until someone has solved the previous block. So now they got to start over from scratch. And then it looks at this and says, all right, we're 7, so we're going to use this algorithm 7. We're going to use cube hash, right? And then it's going to take the output of cube hash and shove that into the next one, into Shabal. And that'll come out with another number that's somewhere on this number line, right? And then we're going to take the output from that and stick it into echo hashing algorithm, get another number, and then shove that back into the next one. We keep doing that. So we'll take the output of that, put it in Blake. Anyway, you can see kind of how this goes, so I don't have to drag it all. But it goes through all of those, and then the output at the very last one, we check it against the little green rectangle. Did we win? Oh, yes, no. Okay, move on, and we just keep doing that. So my laptop will do about 100,000 of those, right, where it goes through all 16 and gets a result, and it'll do about 100,000 per second. Of doing this. That we actually built this into the software, we released the software, and CPU mining was a thing. You could get the software, download it, start your laptop, and laptops were winning Ravencoin. This is on January 3rd. So that was working great, right? Everybody's clicking along. Patrick Burns, CEO of Overstock, says, hey, you guys mine on your own laptops. We've talked to the lawyers. We're going to let you gotta use the results and get Ravencoin when you're mining. And then about January 20th or so, somebody says, hey, we just built the software to mine on a GPU, which is a lot faster. GPUs, which is a graphic processor, like a gaming rig card that does the gaming stuff, the fast screen. It's just faster at doing this kind of stuff. And so it was like 50, 100 times better. And so anybody who had a GPU was as good as having 100 laptops. And so it made it harder and harder for laptops to do it. Now it's mostly dominated by GPUs. One of the things we're trying to prevent is being dominated by these custom-built machines like the one I have, or it's now obsolete, but I have, that does this trillions of times per second. we'd prefer that people with regular gaming rigs, people who, they can build a rig and they can put 6 video cards on it, stuff like that, those are fine. We just don't want like custom built software. So that's one of the things we're trying to prevent with this, and so far so good.
How are you preventing against that?
So a couple things. One, this is a little bit tricky to do. You have to build the chips to do all 16 algorithms. You have to handle all this rotation. It's not impossible. We call it ASIC resistant, not ASIC proof. More importantly, we've come out and publicly said, hey, if we see an ASIC, meaning someone's out there trying to sell it, which would be part of their model, right? Sell the picks, sell the shovels. They come out there and do that. We're going to change the algorithm. So kind of the whole community knows that.
Sorry.
Yeah.
It costs about $5 million for somebody to build an ASIC, and so they've got to recoup their costs for building the first one.
Either by out-mining everyone or selling them. Yeah, and we're going to try to obsolete them by the time they, before they recoup their costs. It's just a statement and kind of pre-doing some code that can do some things that they don't know about and we won't talk about because that's part of the trick.
So how do you just change it?
So the trick is that the community would have to agree. We can write the software. We can change the software fairly easily. I mean, even if
everyone's computer would have to adopt it.
Yeah,
they would.
They'd have to download the new software.
So how do you do that?
We would basically talk to the community. So not everyone. So this is an interesting thing. All the miners and the economic actors. So everybody else, it's like, everybody else is running the software. They might be on the other chain. They might try to spend the chain, but as long as they can't they can't trick an exchange or trick a merchant like an overstock, then really you just need to get more than half the hash power of the miners and the economic actors, which would be the merchants and the exchanges. And so those people would have to switch. It's totally voluntary on their part, but that's what and we've just published that we would do this, right?
Now it's realistic when it's early.
Yeah.
Our community knows.
It'll get harder and harder, for sure.
Yeah.
Yeah.
But when it's someone can make $5 million by building an ASIC chip, you assume there's a lot more
They're not going to want
players involved, a lot more people who can switch.
Yeah.
Or you have to convince.
Yes, agreed. Yeah, no, it's even a little bit in the game theoretic kind of realm in that, like, if someone was going to build one, they would know that our paper says, hey, if we see this, we're going to switch or try to switch, will be a deterrent, right? Because they're like, hey, we were going to build this, we're going to invest the money, and then we may or may not recoup our money before they get it switched. I mean, it would be a game, it's kind of a game theoretical kind of concept of just even saying that we'll switch. So we have a great community. So these slides are available, by the way. At the end of this, there's a barcode, and you can get the read-only version of this. This has links, right? There's links. If you click on this big graphic, it takes you to a link, and it'll take you links to these links, the iOS wallet, all of that kind of stuff's all linked. But we have a Ravencoin talk, Bitcoin talk, Twitter, Discord, Telegram, Reddit, GitHub, which is where we put the code. It's all open source. You can copy, you can play with it, you can look at it, you can find bugs, send us information. It's super public. Yeah.
About the iOS wallet.
Yeah.
So obviously that's not something you can really do with, say, Bitcoin because of the size of the blockchain, having it on your phone.
Yeah.
Take forever to download.
So there are lots and lots and lots of Bitcoin wallets online. They're SPD wallets.
So is this an SPD wallet?
It is an SPD wallet. Yep. SPD wallets are fairly secure. They download all the headers. They verify all the headers. They check all the transactions, make sure the Merkle roots work. So they're very safe, but they're not a full node, right? They don't interoperate and protect the network. So we have 3 main websites, Ravencoin.org, Ravencoin.com, and Get Ravencoin. Great community, by the way. I mean, join the Telegram, the Discord, that kind of thing. Lots of people kind of chatting about this stuff. It's getting really, really chatty right now because of the Binance thing. It's like I opened up, there's like 3,000 messages gone through the Discord in like 18 hours. Ravencoin stats, so ravenstats.info. This kind of tells you what the mining horsepower is currently. So right now we have about 2.7 terahashes per second. Each one of these, each one of those terahashes, each one hash is really 16 hashes. So if If you really want to multiply how many hashing algorithms it went through, you'd have to multiply that number by 16. So how many issued? So we have 5,000 issued every minute, so this is kind of its issuance schedule, and we have a 37,000 difficulty. The more people mine, the more the difficulty goes up, gets a little bit harder, but that usually goes in correspondence with the price. So price and mining difficulty usually kind of go in sort of a lockstep because of economic reasons, right? If it's more profitable to mine, you get 5,000, it's worth more, then you can put more capital expenditure and electricity and stuff to do mining. So if you want to update your song list, your playlist, right, with real hot music here, you can get the Ravencoin songs. There's 4 of them. The links to this are in the presentation if you want to download these. So what's next? So part of this is done. So phase 2 assets, done. Code complete, sitting on GitHub. It's done. It's working on testnet, but we're basically telling it won't activate until we get enough miners to use the new code. And so there's code in there. It uses a thing called BIP9, which is a way for the software to look and make sure that enough people have upgraded to the new software that it should activate, and that you're not going to get a chain split. So as soon as we get 90% people on it, it's going to activate with this. So this is token names. So this is for 500 Raven. So right now the cost of that, roughly 10 bucks. Ravencoin right now is about 2 cents. So 500 of them is about 10 bucks. You can create your own token, so you can make your own name. There's some restrictions. There has to be at least 3 characters, up to 30 characters, things like that. Number of tokens. So you get to decide how many tokens you want. You can say, I want 1, or I want 21 billion, or anywhere in between there. You can say how divisible it is. You can say, I don't want these tokens divisible at all. They're going to represent a cup of coffee at my store or something like that, like a gift card. I don't want them divisible. I don't want anybody holding like 2.2 of these. I want them to be non-divisible. Or you can say I want them to be like Bitcoin, divisible to 8 decimal places, to 1/100,000, right? So you get anywhere in between there. You get to choose. You can make it like pennies, like two decimal places. You get to decide. You also get a check mark. There's a graphical interface for this. You get something you can say, I want this to be reissuable or not reissuable. Here's the difference. If it's reissuable, you get to reissue more. You get to, because you're the owner of it, you can say, I want more of them to exist. The downside to that is if it represents like a share of a company, people go, wait a minute. What if you just reissue more and kind of like water it down or that kind of thing, right? So you get to decide, and people can see whether it's reissuable or not reissuable. You can also, if it's reissuable, you can make it more divisible. So let's say you said, hey, I want these to be units, right? Not divisible. Later on, you change your mind, still reissuable. You can say, now I want really down to 2 decimal places. And you can change that as long as you have it marked as reissuable. While it's reissuable, you can also then mark it not issuable. So you can lock it in at any time. You've increased it, you made it more divisible, that kind of thing, and you can now lock it. So now the chain will make sure that that's the max number of that token that you name that's unique ever. So that's an option. You can also include metadata. Metadata, since all you have is a name, you can call it Bobcoin or whatever you want to name it. You can add metadata. Metadata is just information. It's in JSON format. How many are familiar with JSON format? Kind of a programming term. So it's just a file format that kind of says, like key value, that kind of thing. So you can say contact info and a name and address and who to contact and what does this token do? You can say like a URL that goes with it, maybe a document that goes with it, things like that. So you can basically say, what is this token? Besides it being named Bobcoin, what is it good for? What's the promise behind it, etc. You can put that right into the chain and basically lock it in there. It actually gets stored in